lesson 87, we're going to be doing our last factoring technique of the year. There's one factoring technique, and there's only one factoring technique that we haven't covered, and you'll get it in Algebra 2, and that's the sum and difference of cubes. So let's kind of do a quick overview of our factoring techniques, okay? And we did it based on terms. If we have two terms in a polynomial, what are the methods that we look for, and in what order? We look for GCF first, difference of squares, and then the third method that we're not going to learn in Algebra 1 is cubes, okay? If we have three terms, we look for GCF, and then after that we just do our trial and error factoring. That's where we multiply the first term by the third and find the factors of that product that add up to be the middle term. So we just called that trial and error factoring. And what we're ultimately doing there is we're unfoiling it, right? We're unfoiling the polynomial. We're breaking it up into its multiplied pieces. Today our last factoring technique is factoring four terms or more. There's some methods that you can factor more than four terms by this method. But mostly we'll be looking at four terms. Guess what we're going to look for first, always? The GCF goes all the way back to Unit 3 of the course. We've been factoring GCF out of expressions since Unit 3. And then after that, we're going to factor by grouping. Okay? Grouping is not difficult. You just have to know, if you're looking at four terms, that you've got to look for a GCF, and then we'll factor by grouping. So what am I looking at, and what are its properties? The two big questions that I always want you to ask about a problem when you approach it. What am I looking at? If it's a four-term polynomial and the directions say to factor, we're going to take out a GCF, and then we're going to factor by grouping. And grouping is really just more GCF factoring. So it's not a new factoring skill. You already have the skills necessary to do this. You just have to be instructed on how to do it. Okay?
Are we about to do an example problem?
I think we should probably do an example problem.
Yeah, I think we should.
What do y'all think? Should we do an example?
I think you wait.
All right.
You record this.
It is recorded.
And Mac, you're the star.
All right. Here we go. We have 2x squared plus 4xy plus 7x plus 14y, and our directions here say to factor. How many terms are we looking at? What are we factoring? So I need to look for a GCF.
There is none.
Is there a GCF between all these terms?
Not at all.
No. 2, 4, 7, and 14 don't have any common factors, and they don't all have the same variables either, so we're just kind of stuck with what we have.
Yeah.
All right, so to factor by grouping, here's what we're going to do. We're going to try to just group the terms as they're given. These two and these two. Bless you. And then in each pair of terms, we're going to take out a GCF. Okay? What is the GCF in that first pair of terms? 2x will come out, and I will be left with x plus 2y. Just be careful. Just bring this sign down. Generally, we'll just bring that sign down. And what can I take out of the second? I can take a 7 out, and that'll leave me with x plus 2y.
And that's it.
Okay? Now, you notice something here, right? What do we have?
You distribute.
We have a common, y'all listen, we have a common binomial factor. Now I've broken this up into, how many terms am I looking at here? Two terms, right? Terms are things that are being separated by a plus or minus sign. So I've got this big term and this big term. And both of those terms have a common factor of x plus 2y. So I can take out that common factor, x plus 2y, and what's left is 2x plus 7.
And that's it.
Well, we're going to go back over that because that's the only tricky part, if there is a tricky part. But watch this. Here's how I kind of want you to be able to see this.
Oh, I get it now.
You will. You'll see it. But if I had, instead of this thing and this thing, if I had 2xa plus 7a, isn't it clear I could take an a out? And what would be left is 2x plus 7. But instead of taking out an a, I'm taking out this whole thing. Remember, a parenthesis groups things together,
They're going to
and we
multiply.
treat it like one thing.
They can multiply, so yeah, I think it's good.
Yeah, so I mean, if we multiplied this back out, we'd get what we started with. Do y'all want to prove that?
No.
X times x, 2x is 2x squared, right? X times 7 is 7x. 2y times 2x is 4xy, and 2y times 7 is 14y. So you can still always multiply your answer back to make sure that you get what you started with. Okay? It's really not, this is not a difficult concept. It gets a little tricky when we start throwing positive and negatives in. We have to change signs. We have opposite factors. But it's really pretty straightforward. All right? So this is one where it kind of gets a little tricky. I really don't love this as a second example. I'd rather have an easier second example than this, but we're going to go. We're factoring how many terms here?
4.
How do you factor 4 terms? GCF or grouping. Don't forget the GCF. Do we have a GCF here? No common factors between 3 and 8, and everything doesn't have a y, so I just kind of have to jump to the next thing on my factoring checklist, which is grouping. So I'm going to group these as they are given to us, these and these. And we're going to regroup this one too, and I'll show you how you can regroup things and sometimes make it a little easier on yourself. What can I take out of the first group of terms
Y
here?
squared.
Y squared, and that will leave me with 3 minus 8y. Now, what can I take out of the second term?
Nothing.
Second pair of terms, they don't have anything in common, right? So let's factor out a 1, because all terms have a 1 in common, right? And that's just so we can see this. Now, are these two things the same?
Not at all.
Wait.
Yes, they are,
How
right?
did you get the sign to change it to plus in the middle?
Oh, I just factored a positive 1 out of those two terms. Now, if I factor a positive 1 out, does that change anything? No. So taking a positive 1 out here still leaves me with negative 8y plus 3, which is what I started with. And the reason I factored it out, Gray, is because I need groups. I need 2 groups of things there. This is always the way you're going to do.
But why is it plus 1 instead of
If I factored a minus 1 out, that's a legitimate question. If I factored a negative 1 out there, what would I have left inside? 8y minus 3.
Okay.
Now, is this the same as this? No. They're opposites of each other. So I messed myself up by taking out a negative 1. Now, we're going to regroup this in a second, and I think you'll see when we regroup it's a little easier to work. But these are the same. 3 minus 8y is exactly the same as negative 8y plus 3. You could change the order and they would be exactly the same. So I can factor out a 3 minus 8y, and what am I left with? Y squared plus 1. That's why we pulled that plus 1 out and showed it, so you can kind of easily see what's left behind there. Okay? Now, let's regroup these. Let's regroup. All right? I want to take, which 2 terms kind of look like they go together?
First 2,
Wait, what? I thought we already
the
figured
middle
that.
2 and the last 2, and the first and the last.
3y squared plus 3 minus 8y cubed minus 8y. Don't those kind of go together a little better?
Didn't we get the same answer?
We are going to get the same answer, but I just want to show you that you can regroup these and sometimes make it a little easier on yourself. What can we take out of the first pair of terms here? The 3, right? And that'll leave us with y squared plus 1. What can I take out of the second pair of terms? They're both negative. They're both negative. So I'm going to take out a negative 8y, and that's going to leave me with y squared plus 1. And so what do we have? We have y squared plus 1 times 3 minus 8y.
Okay.
Now, I'll let you decide if that's easier or harder. I think it's easier. It's because you don't have the trickiness of factoring out a positive 1, right? That's a little tricky the way that was first given to us. Okay, example 3. Now, this one,
Does have common.
it does have a common factor. We can see kind of right out of the blocks that there's A's everywhere. And we can see also that there is a 5 that'll go into all of these, right? So step number 1 is to factor out a 5a squared. And probably some of you still writing this down, so let's wait just a second. Don't want anybody to get behind. Okay? So when I take out the 5a squared here, I'm going to do something that we've not done before, just to kind of keep from having parentheses on top of parentheses on top of parentheses. I'm going to use a bracket here. You don't have to do it this way. To me, it just looks a little cleaner. Brackets and parentheses have the same function as far as grouping symbols go. You still distribute through a bracket just like you would a parentheses. What's the first term going to be inside my bracket?
9AB.
9ab minus
3A.
3a plus 3b minus 1. Thank you. And now I have to try to group what's left over. Can I group these two terms? Is there anything common there?
Yes.
Yes.
3A.
3a can come out of that, and that'll leave me with, and here's where you'll kind of see the brackets are helpful. 3a times 3b minus 1. Can I take anything out of the second term, anything interesting out of the second pair of terms? So if I can't take anything interesting out, I'm going to take out a good old boring positive 1, and that'll leave me with 3b minus 1. Say it a little louder there, Robert. 3a plus 1, that's correct. Now we can get rid of the brackets at that point because, it just looks a little better to me when you've got grouping symbols on top of grouping symbols to use brackets instead of parentheses there. All right? So that's about as difficult as you'll see. There's one other little kind of tricky thing that we'll look at as well, but that one is pretty involved. But you got the GCF. You got to remember the plus 1 thing. We're factoring out a positive 1. If they don't have anything interesting in common, they do have a positive 1 in common. Sometimes they'll have a negative 1 in common, and you'll have to take out a negative to make them match up, and I think we're going to look at an example like that in just a second. All right, factor 3a squared b minus 18a plus 30 minus 5ab completely. 3a squared b minus 18a plus 30 minus 5ab. Sarah Catherine, do we have a common factor here? No, we're rolling right along with the 3 on those first 3 terms, but then when we get to the 5, we kind of lose it, right? So nothing is common to all of these terms. Okay? Anybody think we should try to regroup these terms? Just go with it the way it is? All right? Now remember, regrouping is always an option if you want to kind of rearrange terms so that things are together that you want to work with. But you can group them so that it can't be factored, and that would be a bad thing. But do we have a common factor in that first pair of terms?
Yes. 3A.
3 alpha, yes, 3a times AB minus 6. And what can I take out of the second group of terms? So plus 5 would give me 6 minus AB. Now we got to be careful here.
Not the same.
They're not the same, are they? What are they? They're opposites of each other, right? They're not reciprocals, they're opposites. Because in the first term, the 6 is negative. The second, in the second one, the 6 is positive. The AB is positive here, the AB is negative here. So they are opposite signs. They have opposite signs. All right? We can work with opposites, can't we?
Probably.
What if I change this to negative 5? What would that do to the signs inside here? It changes those signs, right? So that would become negative 6 and positive AB. Now, are they the same? Can't I rewrite this as AB minus 6? That's the same thing, right? So if you end up with opposite factors, you can change the signs by just factoring out a negative instead of factoring out a positive. So we'll have AB minus 6 here times 3A minus 5. Now, we haven't checked one of these in a while just to prove to ourselves that this actually works. This is a factorization. What's AB times 3A? 3A squared B. What's AB times negative 5? Negative 5AB, right? And negative 6 times 3A is negative 18A. Negative 6 times negative 5 is positive 30. So keep in mind that you can always, when you factor, you can always multiply things back together to make sure that the factorization is correct. Okay? I don't think we're going to have time to regroup that one. Now, here, this doesn't look like a grouping problem, does it? Now, I want to show you something here that will work. If you like factoring by grouping, this is a really neat thing to do here. Well, how have we been doing these problems? Look for the factors of negative 44 that add up to be negative 7. And what are those terms? So this would be x squared minus 11x plus 4x minus 44. Right? That's what we've been doing. We've been busting up that middle term. In this particular one, we wouldn't have done it that way. We would have just jumped to x minus 11, x plus 4, and be done with it. But I want to show you that you can now factor this by grouping.
If you want to.
Yeah. That's x times x minus 11, right? And this is 4 times x minus 11. You see it? So we're left with x minus 11 times x plus 4. And some of my college algebra students actually like this. If they've gotten to college algebra and they can't figure factoring out, they really like this method, particularly for the more difficult factoring problems. This one we can all do, x minus 11 times x plus 4. 100% of you would get this problem right on a test or quiz today. Okay, but what if the problem gets a little bit more difficult? What if it's like this one? You have to multiply 6 times 10, and that busts up the middle term for us, right? What's 6 times 10 is 60. And what are the factors of 60 that add up to be negative 17? Negative 5k, negative 12k, plus 10. Could I have grouped those a little better?
Yes. You can put 12K and 5K together in 6.
Yeah, I think probably I could put those two together. But let's just go the way we've got them. It's still going to work. What can I take out of these two terms? K times 6k minus 5. What can I take out of these two terms?
2.
2. If I take a 2 out, I have negative 6k plus 5, right? I need to change the 2 to negative because 6k minus 5 and negative 6k plus 5 are opposites. So I need to fix that. I need to change this to negative 2. And that's going to change this to a positive and this to a negative, right? And so now I have 6k minus 5 times k minus 2. Now, for some people, that involves a little less thinking than our other trial and error factoring methods. Okay? You still have to do the hard part, multiply this and find these two factors. Okay? But once you find those two factors, you can indeed use grouping to factor that trinomial. All right? Homework is page 573, A through F, 1 through 4, 7 through 10, 14, 19, 21 through 24, 26. Like, comment, and subscribe.
Are there any